Quick informal poll. Oh, the person who needed a group. Did you find a group? Is there a group that you need a group? You need a group or a group member? You need a group. Who else needs a group? You need a group. You need a group. You need a group. That sounds like a group. Pick one of those two tables that doesn't have other people at it. All right, I notice that there are fewer people here today than there were yesterday. Is it something I said? No? Maybe? Who knows? If you are here, please sit with your group. If you're not here and you're one of the... There was 6 people watching live, and now there's 3. Maybe it was something I said. Well, if you're one of the 3 people that are still with us, and you can communicate with your group via text or whatever, please do that while we're discussing here. I would like this to be interactive today, and I would like us to develop a plan together for going forward. I could just assign you the group assignment that I've used year after year after year for, I don't know, maybe that many years. And maybe tweak it a little bit, make it a little bit different, a little bit better, maybe. I would hope better if I was tweaking it, right? It would be stupid to tweak it on purpose to make it worse. But I would like to... There's like different adjustment buttons that we could press, right? Who's ever operated something where you could adjust, like driven a car? Who's ever driven a car on an icy road? Who's ever had to make adjustments while driving a car on an icy road? How did it work out for you?
I mean, it was okay.
It was okay? So keep your hands up. Keep your hands up. How did it work out for you? Didn't crash. How did it work out? Big adjustments, small adjustments. You guys can put your hands down. I learned to drive. I learned to drive when I was 9 years old. Could have been 8, but 9-ish years old. We lived in a rural area in the Northwest United States, Washington State. And we had this really long, steep gravel driveway. And it got steeper at the top, which is really a bad design choice. And there was a sharp corner at the top. Also bad design choice. My mother was afraid to drive up the driveway because you couldn't get up the driveway unless you were going like 50 at the bottom. And then you'd just slowly slow down as the wheels would spin as you'd get up to the top. And so when I was 9 years old, we started this thing where she would stop the car when she pulled into the driveway and we would switch seats. Because at 9 years old, you're not afraid to put the pedal down, right? So I learned to drive at 9 years old. But then I actually gained my driving experience. We had moved to northern Vermont. And so I always like to say I learned to drive on the side of a mountain in northern Vermont. We had 17 miles of unpaved road to get to town from our house. Best time I ever did was 15 minutes. It was in the middle of winter. Because the road gets... Who's from Vermont? Anybody? Nobody? Wow, there's usually somebody in the class from Vermont. The road gets smoother in the winter because all the washboards and potholes and stuff fill in with ice and snow. And the road gets wider in the winter in Vermont because they know it's going to snow again. So they keep pushing the snowbags back as far as they can and they fill in the ditches and stuff. So, yeah. So anyway, driving on icy roads, make small adjustments. That's the key. When you start making big adjustments, you have lost control. There was, enough icy road stories. But so I usually would not suggest making a big swing at something when I'm changing an assignment. In my experience, changing an assignment with a big swing, well, the people that win the most home runs every year also win the most strikeouts every year. So when you're taking a big swing, you're likely to screw up and mess up. But hey, we only live this one time here, as far as we know. unless we're Hindus, in which case we live over and over again. We're going to take a big swing at this one. The premise will remain the same. So what I always did before, and so you guys know what we make in the labs in ME1800? Does anybody not know what we make? Who does know what we make? Could you describe it for us?
It's a Stirling engine, but it's essentially a tube with a piston in it that moves back and forth.
You guys that didn't know what we make, you got that now? It's actually a thermoacoustic engine, but you model it with the Stirling cycle. So a Stirling engine is slightly different. It was invented by, and Stirling with an I, not an E. If you spell it with an E, you're talking about the silver. If you spell it with an I, you're talking about the guy who invented the Stirling engine. And it was, anyway, he invented it because his parishioners were blowing up when their steam boilers were exploding in their homes. Steam boilers are dangerous, or old-fashioned steam boilers without good relief valves are dangerous. So we make this thermoacoustic engine. So what happens is we have a cylinder. That's one of the components we make. There's a cylinder. In the cylinder, there's a piston. So the tubey thing is the cylinder. And the piston is the bit that slides back and forth in the cylinder. And we attach a test tube to one end of that cylinder. And there's a hole in the end that the test tube attaches to that is smaller. It's the choke point, actually. And the size of that hole is important for the operation of this thermoacoustic engine. But what happens is you heat up the air in the test tube. And we put a little heat sink in there. So we actually put a piece of steel wool in the test tube as a heat sink. To heat up the air in the test tube, what happens to air when you heat it up? PV equals nRT, right? So when you heat up the air expands because we have controlled the volume. Well, we're allowing the volume to change by expanding the air, and it pushes that piston out. As it expands and pushes the piston out, it rushes through that little hole in the end of the cylinder into the cylinder so that it can move the piston. You guys with me? All right, so that happens, but then the air cools down because the cylinder is made out of brass. So the brass soaks up the heat that was in that air, and it cools down, and when it cools down, it contracts, right? And so it pulls the piston back the other direction. And this sounds pretty cool and pretty boring because you'd just be watching it do this, except it goes at like 1,000 cycles a minute. As it does that, it oscillates back and forth. It builds a standing wave in the test tube part, and it bounces that piston back and forth. It actually is pretty cool. And it is an external combustion engine, which means you get to light shit on fire. And lighting shit on fire is fun. Well, for most of us pyromaniacs, it is anyway. I only know of one time an ME1800 student had the police called on them for lighting their Stirling engine or thermoacoustic engine on fire to demonstrate it. Only one time do I know of that the police were called. And when the cops got there, it was WPI police. They just laughed because they knew where it came from and they knew that it was just like a school thing. So the person didn't actually get in trouble, but people they work with did call the cops, which I thought was kind of weird because it was an office on campus too. And the people in the office thought the student who was demonstrating their Stirling engine was, I don't know, lighting stuff on fire. Anyway, so normally what the group project is I say, you in your group are going to form a company that is going to make the components for this Stirling engine or thermoacoustic engine, because that's really what it is. But you're going to make the components as a kit, and then you're going to market that kit online. You don't actually have to do all the marketing parts. We're going to assume that you're able to do that part. And what I want you to do for your group project is to determine what does it take to build the company that makes that Stirling engine. So that's the normal group assignment, and we give you a parts list, and there's stuff you have to buy, and there's stuff you have to make. And we're going to make all those components in the labs of the class. So you're going to learn how to make those things. You're going to find out, you're going to inherently understand how long it takes to make those components and things like that. And you're going to know how long it takes to program them and the engineering parts. So you're going to figure out what the questions I typically ask are, what does it cost to make the first one? And then what do you have to charge for each one in order to make a profit and pay back in 3 years and stuff like that? We go into some detail about that. Because to make, what What goes into the cost of making that first one? What are some things that go into the cost of making one of something if you're going to build a company to create that thing? See, now I got it, I can write notes and you guys can see them if you care. Go ahead. So there's design. Right? Design has cost because you guys are engineers. Many of you want to be design engineers and you want to get paid for that, right? So design has cost. What else costs go into making it or building the company? Yeah. Testing. Now, typically I would throw the testing in with the design, right? You're not done with the design until you've tested it. And I might even include market testing there. So, because we said manufacturing, we're talking about manufacturing companies. Manufacturing is making stuff with the intent to sell it. So if we can't sell it, it doesn't make a lot of sense to make more than that one that we wanted to have on our nightstand. Right? What do you got? So, all right, so there's design and testing. So that's like a category. We got to have that. The equipment. So the other thing that's different about the group project this term is I don't usually talk about it on the third class. I usually wait till we're further into the term, and then I ask you to tell me, all right, what pieces of equipment will you need to make this thermoacoustic engine? We're going to skip that step right now because we haven't all been to the lab and we haven't made half the components yet, which normally we would have done when I'm talking about the group project. So the idea of doing the group project sooner, one is that you actually have more time to do it. The problem with giving you more time to do it is that I'm going to have higher expectations though, right? But if we talk about it every week as we go through and we see how the things we're doing in lecture fit into the group project, then it may help tie the whole class together. That's a theory. And make us feel like we're learning something on purpose with an end goal. So we won't go into exactly what manufacturing equipment it takes, but it's going to take manufacturing equipment. What else are we going to need if we're going to have a company that's going to make a product like this? Yeah. We're going to need the materials for each one. And so, and again, in the normal course of this, we would talk about what materials it was, but it doesn't matter at this point what materials. We're going to need the materials, which means we're going to have a material supplier. We're going to have to know how much we need. We'll know how much we need by the design stuff, right? So we're going to need to have the materials. What else are we going to need if we're going to do this project? We're going to build a company to make a product that we intend to sell to people. Yeah. We're going to need a workforce. Now let's think about that workforce for just a minute, because there's more than one part of the workforce. So what kind of workers do we need for a company that manufactures, for a company that makes stuff? And in this case, we're specifically talking about making a consumer product. And I will tell you that in all instances, we've said we were going to sell direct to consumers. So we'd set up like a website and have people order them and we make them and ship them and stuff like that. Because we can all envision that, right? We've all ordered stuff from a website. Pretty sure at this point in history, everybody in the room has ordered something from a website. It may in fact have been WPI, right? The application was online, was it? So technically you ordered this class from a website, if you think about it. All right. So what kind of workers do we need? Yeah. So we're going to need some machinists. That's assuming that we're making this thermoacoustic engine and we know that it has machined components in it. Yep. We're going to need some shipping and receiving people. My first job in manufacturing was driving a fork truck. Actually, is a clamp truck. So it's like a forklift, but instead of having forks that lift pallets up, it had clamps that could squeeze boxes. So it's a clamp truck, but it's the same thing. At a company that made plastic crap. That a giant room full of plastic injection molding machines. And who's ever been to a Walmart? Who's walked down the aisle with all the plastic crap in it, like milk crates and stuff like that? Yeah. If you walked through a Walmart down the aisle with plastic milk crates in it, that's the factory. They were all made here in Worcester. Pretty sure all the Walmart plastic milk crates sold in the United States were made here in Worcester in that factory. It was our biggest product. We would load entire 53-foot tractor trailers just full of those just to go to Walmart's. They were junk too. Hang out behind the grocery store and steal real milk crates, because real milk crates are actually durable and they're useful. These plastic crappy ones, they're junk. Anyway, so that was my first exposure to manufacturing, was working as a shipping and receiving person, filling up tractor trailers with junk. But it was manufactured junk. So we're going to need shipping and receiving. We're going to need machinists. We'll call those the admin people. And so those are like the people that answer the phones, the people that do the accounting, keep the books, the people and those people are important because they make sure we get our paychecks on time, right? So the admin people, even the janitorial staff. When I first became a CEO, I was too cheap to hire janitorial staff or hire a service to come do that. So that's one of the primary jobs of a CEO at a startup, is emptying the trash and cleaning the bathrooms. That's what we're talking about here, right? We're talking about building a startup company to manufacture these things. So we're going to need some admin people, machinists, shipping and receiving admin people. What else? What other kind of people are we going to need? We're going to need some marketing people. And I'm going to call sales and marketing, although it's really two different functions, but sales and marketing. What other kind of people do we want? Yep.
Someone to assemble.
So we said machinists before, but we don't want the machinists doing sort of the grunt work, right? Because machinists, I don't know, does anybody here know anybody that is a machinist? So they're pretty skilled. If they're actually a machinist, they're pretty skilled. They may call themselves a machinist and not be one. But if you know somebody that's actually a machinist, they're pretty skilled. I've been to plenty of small machine shop companies where the owner doesn't make the most money. It might be the sales person that makes the most money because they get paid on commission and stuff like that. But the highest salaried employees at those companies are the machinists, because they're the most important people. They're the people that do the programming, set up the machines, make sure it's not going to break. And then you have machine operators or assembly people. So we're going to have more general labor. Let's call them operators. And they're less skilled than the machinists. They may be learning, studying to become machinists, and they may aspire to be machinists at some point, but they have less skill. That we pay them less. So, for example, here in Massachusetts, a skilled machinist will be making over $100,000 a year. And a starting operator kind of person, $15, $16 an hour, maybe 17, 18 if they've got some skill. But just off the street, Joe off the sidewalk has never seen the machines before, 15, 16 bucks an hour. Once you start developing some skills, 18, 20, 22 bucks an hour. So what's 22 bucks an hour at a 40-hour week? What's that salary? Anybody? Calculator? Around $40,000 a year. So a skilled operator is making around $40,000 a year. A skilled machinist making around $100,000 a year. The owner, depends on how much money the company's making. Might be making around $200,000. The sales guy might be making around $250,000. So in that range. And often in these small machine shops, the owner is a machinist. So they're, double dipping there a little bit. Okay, so we need some machinists, some shipping and receiving people, some admin people, some sales and marketing people, some operators. Do we need anybody else? It's going to be a small, lean business. And those are really not necessarily the people we need. Those are the skills we need, right?
This could be folded into like many of the other roles that you need someone to keep track of material supply and order more when needed.
So we need somebody to do purchasing. And that may be somebody in the admin. Often those people sit in an office typically. So sometimes we group them in with the admin. But is this the kind of people we're going to need to have our small manufacturing company? Yeah. We might need some design and engineering. It's also possible that we create a company that uses somebody else's design, or we create a company where people send us their designs and we just make them the parts. So it is possible to have a small manufacturing company without any, I wouldn't say without any engineering knowledge, but you might not have somebody with an engineering degree. There's plenty of skilled engineers out there that never went to school and got a degree. All right, but does that cover the people? I think it does. Maybe some other incidental people. You may need a mascot. You may need somebody to walk the dog, stuff like that. But typically that falls on the owner and CEO to do all of those tasks that nobody else is doing. All right, so we need a workforce. So we got equipment, materials, workforce, design. So we know what we want. We've got the idea. What else are we going to need to create our company? Yes. We're going to need a location. I suppose if we were doing Amazon drop shipping, right? So if we were buying stuff from deepest, darkest China and putting up an Amazon page and then direct fulfilling from our deepest, darkest China contact from Alibaba, then we wouldn't necessarily need a location. You can run that business from your kitchen table. But if we're actually going to be the manufacturer like we say we want to be, then we're going to have a physical location to do the manufacturing. And that location is going to come with things like taxes and rent or a mortgage payment, insurance, taxes, rent, insurance. If it's in Worcester, snow removal, at least part of the year, and heat, other utilities. I mean, you guys are going to want to check your email, right? Check for orders. You're going to need internet. Did you know that in Worcester, your choices are pretty limited for internet? Pretty limited. You can pretty much go with Charter or get a Pringles can and aim it at WPI. When I opened an office in Worcester, I wish that I'd gone with the Pringles can because it was close enough. It would have worked. But I went with Charter. It was $250 a month to have the same internet that I have at home for $60 a month because it was a business. $250 a month. It's crazy. I understand you can negotiate that, but I never bothered to just fix the bottom line problems, but adding more sales, right? Okay, but is this what we need? We're going to need a design. We're going to need equipment. We're going to need materials for each piece. We're going to need a location, and we're going to need a workforce. Can we build a company with that? Yes. We are going to need capital. Can you guys see that? I can't see it very well. I do need new glasses though. But we're going to need capital. So capital is the kind of money that we invest in our business in order to, well, basically do all these things, to acquire all of those things. So we're going to need capital to get this started. And that actually is sort of the culmination of the project, is what I want you to do for the project is to make a 4-page business plan You may have to have some supporting documents that go with it, and you're going to have the whole term to do this. But it's going to be a 4-page business plan that would convince me as an investor to invest my capital in your startup idea. And so to do that, you're going to have to be able to tell me how much, how quickly you're going to get it back, how you're going to get it back, and convince me that you know how to do the project. You don't have to have actually spent any money yet, but you're going to have to convince me that you actually know what machines you need to do the project, that you actually know how long it's going to take to make the parts, how much it's going to cost to make each of those parts based on how much time and how much materials and all that stuff, that you know how much you have to sell the parts for in order to get that back. And this is not a business class. It's not a marketing class. So I'm not going to have you go out and do like market projections and tell me that you know that you can make those sales. We're going to skip that part of it because this is not a business class. But the engineering part of understanding how to do this is an important step. So that's what we're going to be thinking about in the back of our minds as we go through the rest of the term. Here's where it's going to be different. So normally I tell you the product is the thermoacoustic engine. Here's the list of the components that go into it. Here's the ones we buy. Here's the suppliers we buy them from even. And so you can tell us how much it's going to cost. And, you know, doing it that way, very structured like that, it's pretty easy for me to grade, right? Because everybody's sort of giving me back the same thing. But it doesn't allow you to experience, what's the word? Your innovative idea-ness. I don't know if that's a word or not. But it doesn't really allow you to stretch your capacity to what you want to be thinking about and talking about. And so instead of telling you it's going to be a thermoacoustic engine, I'm going to tell you at the beginning here, that's also why I'm giving you 6 weeks to do it instead of 3 weeks or 2 weeks to do it, is the first task is going to be to decide what it is you want to manufacture. I will require that you create a manufacturing company. So the basis of getting revenue has got to be making something that you sell to somebody else in exchange for money. And you have to be integral to the making. So it's not order all the stuff from, and you could totally do this. You could design these things. You could order all the components from a company in China, have them air freighted to you. You don't have to worry about all those ships backed up at the ports because these are small, lightweight pieces. They will air freight them to you. You get a 2-week turnaround on a design that you send over there. You get the parts back in 2 weeks, assemble it, and you could totally build a business around just doing that final assembly or just drop shipping the stuff that you outsource to China. This class isn't about how do you do good outsourcing to China. Again, that would be a business class. In fact, I don't even think you could do that at a business class at a university. You'd have to go online and find somebody that's doing that wants to sell coaching. Because that's more advanced than what they teach here. Supply chain management, maybe you talk about that, but the supply chain management classes, they're always talking about ginormous corporations that are building jumbo jets and things like that. Most manufacturing happens at companies with less than 20 employees. Most manufacturing happens in the US in companies with less than 20 employees. So let's assume that we're going to be associated with some of those companies as we grow up. So that's the project. The first step in this project then is going to be, as a group together, identify what you want to do in your manufacturing company, what kind of things you want to make. Do you want to make consumer products? Do you want to do B2C sales? And you're going to spend like 1 week on this. Like we're not going to drag this out. It shouldn't be a long, hard task because again, this is a class project. You're not actually creating a startup that's going to actually go out and raise capital and risk other people's money, right? So don't put too much pressure on yourself. If you feel like this is putting too much pressure on you, the first COVID term, it was like D term 2 years ago, the first COVID term. I had been doing this project for a long time. But I didn't have people form groups because we were fully remote, right? I mean, I was literally teaching ME1800 from my kitchen. My wife made, after that first term of ME1800, my wife made me build a home office because our kitchen has no doors. And she's like, the rest of the family is tired of listening to you lecture. So 'cause I guess I get excited. And you see me walk around the room here, right? You should see me trying to do it behind a camera in my kitchen. We had a whiteboard on the wall and stuff. Yeah, COVID was bad because my office was like, already I was a little bit overweight. I was trying to lose weight at the time. And then I moved to the kitchen, where right on the other side of that camera was the fridge. Double doors, slide out freezer, double doors, full of stuff, food. And just over my left shoulder, liquor cabinet. Yeah, so COVID sucked. But, and we did all learn on Zoom that if it was in a coffee cup, nobody knows what you're drinking. If you take the olives out and like eat them off the little toothpick thing, then they get the idea. But, all right. So the first task is going to be to decide, what do you want to make? And so what are our options here, right? We talked a little bit yesterday about the types of manufacturing companies we could have. So we could be an OEM. So your options are, it's hard to lick your finger and then move papers. Stick it through the mask. Who has that trouble at the grocery store buying like fruit and vegetables? You got to open the bags. And what you always did was you licked your index finger and then you did this with the end of the bag and then you could open it up, right? That's what I always did. And then when we were all nervous about getting COVID, I'm looking around for some, like, oh, maybe they just sprayed the broccoli. Maybe I can go get some liquid off the broccoli and then open up the... Finally, I just figured out you can stick your finger up under your mask and lick it. But that's weird, though, isn't it? That's like awkward. Yeah. Anyways, you got to open the thing to put the fruit in. All right. So what types of companies could we have? We could have an OEM. We mentioned OEM companies yesterday. So the OEMs are the people that make the goods that go to the consumer. So it's the original equipment manufacturer is what OEM stands for. So we could be an OEM, and you could design something, and I suppose you'd call this a vertically integrated OEM because you're going to design something and you're going to make the components and then sell them to the customers. A lot of OEMs are not that vertically integrated. They actually buy all the subcomponents from somebody else. They maybe do final assembly and ship it out. But so you could be an OEM, and you could come up with a consumer product that you're going to sell. I don't want you to put a lot of time into design here, right? Because this is not a design class. I mean, if you're excited about it and you want to do that, put as much time into it as you want to. But this is not a design class. It's not about getting the design perfect and finding the perfect consumer product. If you guys want to talk about that, I'm happy to talk about it offline. It's a super interesting topic for me. I'm really excited about it. But this is not what this class is about. So you could pick something that you already know gets made, right? Something. So our company for a while, we sold fidget spinners. The little machined aluminum fidget spinners, and you spin them. And we sold fidget spinners on Amazon because we thought fidget spinners were cool. Because, well, probably everybody in the room has a little bit of ADHD, right? Right? We all think fidget spinners are a little bit cool. So anyway, we did that right up until Amazon changed the rules and classified all fidget spinners as toys. Toys must pass ASTM toy testing standards. And there's no way our fidget spinners were going to pass that test because we were using brass that was 3% lead as one of the components. We were marketing ours to not children. But anyway, so it worked out perfectly because they kept reordering, and we said, no, we're not going to fulfill those orders. We've stopped manufacturing that product. And we ended up only having to buy 2 of them back from Amazon, which was pretty cool. Because they charge, it costs more to buy it back than you make if they sell one. Amazon is not nice to their vendors in that sense. So you could be an OEM and you could sell through Amazon. That'd be fine. But think of something that you think you could make. You don't have to go through all the design work in detail because you don't actually have to make it unless you want to. What else could we do if we're not an OEM? Yes. So we could be in the B2B area, or sometimes B2B, or we could be a lower tier manufacturer. And so these tiers is really about how far away from the OEM are you. So a tier 1 manufacturer are the people that sell stuff directly to the OEM. Tier 2 sell stuff to tier 1 companies who then repackage it. Maybe they combine it together and sell it directly to the OEM. So you could be somewhere down there. And in fact, one company could be at many different tiers and many different supply chains, right? You could be an OEM and a tier 1 supplier to somebody else. And you could be a tier 27 supplier. I mean, 27 is pretty deep, but you get the picture, right? So our company was like tier 3 to SpaceX on some parts, right? So we didn't deal directly with SpaceX. We dealt with a company who sold them to Raytheon, who sold them to SpaceX or something like that, right? So and I wasn't supposed to know they were for SpaceX. But since I wasn't supposed to know they were for SpaceX, I can freely tell you because I don't officially know that. Except they were little mirrors, and they were, it's great because they were consumable. And they're little mirrors that went on every rocket that went up, and it was part of the laser guidance thing or something. I don't know. Anyway, so you could be down in that tier. So if you were designing, so the OEM is pretty obvious, right? You have to know what equipment it takes to make the parts that you want to make, and then say, all right, that's this equipment, and we're going to have to do this. What if you were designing a company to be down maybe a tier 2, tier 3 supplier? What would you have to pick out then? What are the things you'd have to decide if you were going to design that company and then go ask for capital to get the assets to create it? Yep.
How do you make a markup?
So a lot of that work would be doing prototype manufacturing. So you might make prototype parts for companies that have designs that want to either be OEMs or supply OEMs. So you may do a lot of that prototype manufacturing. But if you want to be in that business of either doing prototype manufacturing, small production runs, large production runs for these companies, what's the first thing you're going to have to decide is sort of what industry sector do you want to be in, right? So do you want to be making medical device components? Do you want to be making aerospace components? Do you want to be making strictly defense-related components? Or do you want to make strictly automotive components? So of course, you could work in more than one sector. But for the purpose of the assignment here, let's pick one and focus our business around, all right, so if we're going to be a tier 2 supplier in the aerospace industry, so there's certain kinds of equipment that we're going to need then in order to fulfill that, that ability, right? So you're probably not going to be a tier 2 or tier 3 supplier to Boeing if you only own like a desktop Shapeco CNC, what's the one they have downstairs? Is it a Shapeco? Anyway, if you only own one of those little machines, you probably won't be supplying parts to Boeing. So you're going to have to know what kind of tolerances do they expect? What kind of throughputs are you going to be expected? And then you're going to have to research the different types of machine tools to find out who can, what machines can meet these needs. Yeah. You're going to have to know what certifications you need. So if it's defense related, you're going to have Itar certification. Itar certification means, well, basically you won't let any enemies of the United States get access to any of the information about how you made the parts. That's the purpose of the Itar thing. It's to keep foreign spies from learning how we make our missiles and stuff like that. So if you're making, parts that are going in missile defense systems and stuff like that, you got well, in order to even have the drawing for the part and know what it's for, you've got to have like a top secret security clearance. The person does. And then your company has to have this Itar certification, which is, it keeps track of how you store those special files and how you make sure that no non-Americans get access to them, stuff like that. WPI does Itar work. Some of the labs do research and stuff like that. And so in those labs, no foreign nationals can go inside the room. Or no foreign nationals can go inside the room if the file cabinet's open. Things like that. So you'll have to, if you decide aerospace, you'll figure out what kind of ISO specifications and things like that you need to be an effective aerospace company. How are you going to do that? Just out of, as a step. So if you said, all right, we want to, so I've told you about Itar. So if you're doing defense, you need Itar. If you say, I want to do automotive. So I want to make parts for General Motors, Ford. Maybe I want to make parts for F1 or NASCAR, right? You could do performance parts for cars too. So you say, I want to do automotive. How would you determine what kind of certifications you need? It's going to be part of the project. So I would start with Google, right? Find some associations. So are there societies that people who have those kind of companies belong to? Ask there. You can even send an email. So find a company that's doing that kind of work in that niche and send an email to their engineering department. I mean, I wouldn't bother the sales guys, but send an email to the engineers. They're going to love that. I'm a student at, find out from the alumni office. Oh, they're going to hate it. I told you this. Here's a thing you can do. And this works really good if you're looking for a job. Anybody think they might want a job someday? Right? We all stayed standing when I asked about the trust funds. So you can find the company you want to work for, especially if it's a bigger company. It's harder to do, I suppose, with a smaller company, but find the company you want to work for and then find out from the alumni office all the WPI alumni that work there. And then this is what I did when I was a senior here. And I wanted to move to Seattle. My girlfriend at the time was going to go to grad school at University of Washington in Seattle. And so we're going to go out there. So for spring break, senior year, everybody else went to Florida. We went to Seattle. It was not warm. It did not rain every day. I don't think. But here's what I did. And back then they had books of this. Like you go to the alumni office and you like check out the book of alumni. Now I'm sure it's all online. But I went through and I found all the people that had graduated like 15 years before who lived in the Seattle area and what companies they worked for. And then I sent them all a letter. I actually wrote letters. I think I typed them and then signed them. Sent them all a letter, said, hey, I'm going to be out in the Seattle area during spring break. I want to... I'm just wondering if I could pick your brain and ask for some advice about any companies that might be hiring in the area. And I picked people that had graduated like 15 years before because I knew that they would be at the level to be hiring managers at this point, right? We were there for a week, never paid for lunch, paid for 2 dinners, had 7 job interviews, and 3 offers by the end of the week. That's how you get a job. And then she decided to not go to University of Washington, so we didn't move to Seattle. But that's life. C'est la vie, right? All right, so the first task for your group is going to be to decide, do you want to be an OEM? And if you want to be an OEM, what product? What do you want to make? Or do you want to do B2B sales? And if you want to do B2B sales, what industry do you want to be at? And what do you want to specialize in? Do you want to, and so in labs, and so who's got lab today? Like 25% of you probably, right? So in labs today, you're going to actually make one of the components for the Stirling engine. And by make, I mean, you're going to observe the machine tool while it makes it, because you probably are not yet a CNC operator. By the end of today, you will be a CNC operator if you have lab today. By the end of tomorrow, everybody in the room will be a CNC operator. Because I can train a CNC operator in 15 minutes. Here's the machine. Here's how the doors work. Here's the start button. If it makes a bad noise, hit the e-stop. Some practice hitting the e-stop. If it makes a bad noise, hit the e-stop. How do you know it's a bad noise? Don't worry, you'll know. If you're cutting aluminum and it makes sparks, hit the e-stop. Aluminum does not make sparks. But if you're cutting aluminum and it makes sparks, that means you're also cutting the steel fixturing. Yeah, and so you put the part in, close the vise, take the part out, put the part on a tray, you're a CNC operator. I once trained a high school kid to operate a cell of 6 machines in 15 minutes. So you had to like take parts out of one machine, move them to another machine, and then this like he spent a couple hours then walking around, moving all the parts through all the machines. We're making little trinkets for some event that was happening here at WPI, handing them out, and this kid was a volunteer. It was a lot of fun. I forgot to teach him to do the inspection step. He did make a bunch of bad parts because he wasn't looking at them, and if you put it in the fixture a little bit crooked the first time, then it wasn't flat anymore when you put it in the other side up. And yeah, so don't forget to look at the parts when you're in lab. But anyway, so the task for this week, and I think I don't want to spend a lot of lecture time on this in class unless you have specific questions. But I'm going to be putting out new tasks every week for working on the project. And so if you do those tasks as we go, you will have a very nice and relaxed final week of the term. If you wait until the final week of the term, which I know is tempting, I was always the guy that wanted to wait till the end because, well, I had other stuff to do today. So I didn't want to do all this stuff for the, don't wait till the end. It's never as much fun. And if I offer to give you extra time, especially on the final exam, do not accept it. Tell me no. There will be no extra time on this exam because I've been the person in their room trying to finish that final project the day after the term ended when everybody else was having a party on the other side of the door. And it is really hard to do a good job then. And, you know, if you got extra time on your project, when the professor's grading it, it stands out because they know that you had extra time because maybe it's the last one they're grading. So if you get extra time, then you have to do extra good. It's really hard to do extra good when you got the extra time. But anyway, so don't let me give you extra time. And with that said, I'm pretty flexible. So if anybody needs extra time, it's yours to have. Just don't accept it. Do what you got to do to get it done before needing the extra time. So this week's task is just as a group decide what you want to make. I'm gonna make some. I'll post a video with instructions about this. But no, we have class again tomorrow, right? I will clarify tomorrow, but I'll put up a thing on Canvas where you can like actually have an official group space in the Canvas site, so you guys can communicate there, and then I can give some group assignments. And so I'll ask for some just progress reports as we're going through the term to try to keep you on track, so that you get those things. Anything else? Oh, if you don't have a group, especially if you're at home and don't have a group, I will also put up a discussion forum thread on the Canvas site, so you can say, I need a group, and then we'll find the groups that don't have enough people, and we'll pair people up with groups. Perfect. Thank you for being here. And this was better. I have decided I hate this room. I really wanted to be in this room to find out if I liked it, and I've decided I hate this room because there's no easy access whiteboards. They're all up against the walls. You guys are between me and the whiteboards, and if I write on the whiteboard over here, those people can't see it and get punched in the face when I point at it. So I don't like this room.
It's nice that you can do everything easily on the computer.